Alright guys, welcome to 9.4. Now, there are 4 series that you are going to have to memorize. Okay, these are called the elementary series. Alright, let's write them down. Now, we actually did these problems. One was sine. We did all the derivatives of sine. If you remember, it was here. There we go. Okay, and it's centered on 0. Elementary series are centered on 0. And remember, every other term crossed out, and we got this for sine. Okay? X to the 1, x to the 3 over 3 factorial, x to the 5 over 5 factorial. Alright, so, let's go here and let's list this out. But from now on, you're not going to find it by doing all these derivatives. You're just going to memorize it. Okay? And it goes like this. X minus x third over 3 factorial plus x5 over 5 factorial minus, sorry, my pen is wigging out, okay, x7 over 7 factorial, right, plus dot, dot, dot. Now, the general term for this goes like this. -1 to the n, because it alternates, okay, x to the 2n plus 1 over 2n plus 1 factorial. Okay, however, and then we put plus dot, dot, dot. You do not, for the AP test, really need to memorize the general term. I don't know if I'd worry about memorizing it. You can kind of just come up with it. The main thing I want you to memorize is that this is odds and it's alternating, okay? So that's what you need to remember. It's the odd exponents and the odd factorials, and it alternates every time. Okay, our next one is cosine. Now, we did do an elementary series for cosine. We just, it was around, I think, cosine x equals pi. So it was like slightly different, but anyway, I'll just tell you what the cosine one is. Remember, because these derivatives, it did the same thing. Every other one was 0, right? Here's what the cosine one is. 1, x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. Okay? So it's really easy to remember sine and cosine. You just remember sine is odds, cosine is evens, and they both alternate. And this is even because, like, right here is x to the 0, so it goes 0, 2, 4, 6. So it does start with that constant. You want to remember that. Alright. Now this one, it alternates. But because it's just the evens, it's x to the 2n over 2n factorial. Okay? Again, not super necessary to memorize the general term, but you can if you want. E we've been using since almost the beginning of this chapter, right? E is every term does not alternate. Okay, so E is x to the n over n factorial. And we've done that a few times. And then we also did do ln, so I'm not going to go back and look for it, but we did that. Remember, it was about x minus 1, and we had to change it to x, so it's a little tricky. So ln is this over 2, x minus 1/3 over 3. The next one would be minus x minus 1/4 over 4. The general term would be -1 to the n, x minus 1 to the n over n. Now, you always want to kind of check these when you do them. This is actually not quite it yet because, okay, n, right, which means that this is the second term, but the second term is negative. This is making the second term positive, and like this is the third term, and the third term is positive, and if I put -1 to the 3, the third term would be negative. Okay? So you do just kind of have to check that. So the general term on this one is you can either write n plus 1 or n minus 1, and that will do it for you. Okay, so let's go ahead and let's look at some patterns that I think will help you memorize these. So sine, we're going to remember, is the odds and it's alternating. Cosine is the evens and it's alternating. Right? E to the x is all numbers, both odds and evens. And this one is the only one that is not alternating. Okay? So like, I don't know, like underline that or something. The e to the x is not alternating. And then ln of x is tricky. You just got to remember x minus 1. The way that I remember that is because the ln of 0 doesn't exist, so we can't go around 0, so we have to move it over to 1. That's kind of how I remember that. And then this one is alternating. And the other big difference for ln is, look, it's the only one that does not have factorials. It just has regular numbers on the bottom. So the other thing I'm going to memorize for this is no factorials. Okay? So e is the only one that's not alternating. ln is the only one that has no factorials. And then ln is like shifted over to x minus 1. So we're going to just memorize those. You're going to need them enough, okay? So we can create new series by just like using the ones we have. So for example, sine of x squared. Okay, so you would remember, all right, sine is odds alternating. So right now I'm not writing x squared yet. Right now I'm just writing sine. Okay, but when I plug in x squared, each of these I plug in squared, so this actually turns to x squared. Now x squared to the third would go to the sixth, and x squared to the fifth would go to the 10th. Okay? Alright, so we get that. Now you can, you basically just write these. Just think about putting an x squared in there. X squared to the 2n minus 1. That's all you have to do. We're just putting in an x squared. So my general term, negative 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. So I basically am just going to write that. And where it's x to the 2n plus 1 over 2n plus 1 factorial, I'm going to just put in an x squared. And it ends up being x to the 4n plus 2, but you don't have to go that far, okay? Always at the end put a plus dot dot dot. You do lose points for that kind of stuff, and that would be like real annoying. Okay, cosine square root x. So I remember that cosine starts with odds. Sorry, cosines is evens, not odds. I'm doing this backwards. So it's 1 minus, and then it's x squared over 2 factorial, x4 over 4 factorial, x6 over 6 factorial. Okay, that's cosine. So all I'm going to do now is plug in square root x wherever I see x. Okay, so this is going to be square root of x squared. This is going to be square root of x fourth. This is going to be square root of x sixth. Okay, and we'll like write that down simplified in just a minute here. The cosine one was x to the 2n over 2n factorial. Well, now I'm putting a square root x in there. Okay, and that would be fine on like an FRQ or something. That would be great. Now on a multiple choice, they might reduce that a little bit for you. Move this up a little bit so we can see. So I have space. These are all kind of very close together. So, square root of x squared is just x. Square root of x to the fourth is x squared. Square root of x to the sixth is x to the third. So it's alternating. Square root of x to the 2n, you guys, it's like x to the 1/2 to the 2n. So that's just x to the n, right? So it's alternating x to the n, and it's still, oh, I gotta put that in parentheses, 2n factorial. If you don't put 2n factorial in parentheses, it means only the n is factorial. We need to put 2n factorial. Okay, perfect. All right, let's look at x e to the x. Okay, sorry, I took up a little bit of space with that one. All right, so x e to the x. Well, we know what e to the x is. E to the x is 1 plus x squared over 2 factorial, x third over 3 factorial, x fourth over 4 factorial. Does not alternate. Xn over n factorial. Okay, but this x out in front means I am multiplying everything by an x. So now this actually becomes x, and then x times x is x squared. This becomes x to the third. This becomes x to the fourth. This becomes x to the fifth. Okay, and then what does this become? Well, every time I multiplied by an x, so just think about it. What does x to the n times x become? Well, if that's x to the n, x to 1, it becomes x to the n plus 1. Because when you multiply, you are adding the exponents. Okay? Great. All right. Now, just got to put these lines in between so you guys can kind of see. Trying to use different colors, but anyway. All right, now you guys, 1 over x, how can I get that from one of these elementary series? Sine, cosine, e, or ln. Well, what you might think of is that ln of x, the derivative of ln is 1 over x, right? And so what I'm going to do is say that I'm just going to take the derivative of the ln series. All right, now put this up. So what we're looking at is this. This is the ln series, and I'm going to take the derivative of that. So kind of keep your eye on that while I'm going through here. Okay, so right here, the derivative of x minus 1 is 1. Okay, now I'm over here. Now, notice, when the 2 comes down in front, it looks like this. 2x minus 1 to the first over 2. We'll simplify all these in a minute. When the 3 comes down in front, it's 3x minus 1 over 3 to the second. When the 4 comes down in front, so I'm just doing my derivatives, 4x minus 1 to the third over 4. And I'm even going to do it, you can even do it with this one. Remember that alternating piece is constant, so it stays the alternating piece, which we'll just check at the end, but that constant stays, and then it's n x minus 1 to the n minus 1 over n. And if you notice, what happens with every single one of these is that cancels, that cancels, that cancels, that cancels. Okay? So like all of those things canceling out means I essentially just like get rid of them. I can minus them now. I would maybe write it again, but they did not give me enough room to write it again. Those all canceled out, and including even the n canceled out. So they're not really fractions anymore. And it just becomes, move this closer here. Alright? Now, in order for this is how I check. In order for this to work, it has to be x minus 1 to the 0. In order to be to the 0, n has to be 1. And then for the next one, in order for it to be 1, n has to be 2. So this is the 2 term, the 3 term. So let's check if like my signs are right. Well, 1 minus 1 is 0, and negative 1 to the 0 is positive. 2 minus 1 is 1, and negative 1 to the 1 is negative. So that is right. So I just kind of like check it and make sure my alternating stuff alternates correctly there. Okay? Okay, for our last one here, we're going to do the integral of ln. Again, using this whole big thing up here. So let's see if I can erase like what I've drawn. All right, and we're going to do the integral of ln. Okay, evaluated from 1 to t. And here's the thing, guys, like, normally ln does not have an integral. We have a derivative, and we can't find it. But remember that what we're doing in this chapter is we're turning transcendental functions into polynomial functions, and we can take the derivative and integrals of those very easily. Like, now we know the derivative is 1 over x. We could probably do a geometric power series over here. Remember how it's 1 over 1 minus r? And in this case, r would be like 1 minus x, right? Because then it's 1 minus 1 minus x. Anyway, and that's 1 over x. And I could write a power series, and I could get like this exact same thing. Okay? All right. Let's see here. So now, let's go ahead and just integrate this ln one. So anything to the first goes squared over 2. Minus, to the second goes third over 3. Now that 2 is still there on the bottom. So then it ends up being 2 times 3. And I'm actually not going to put them together, and you'll see why. It's more to make my general term. That's 4 over 4. And then that's 5 over 5. And by the way, the reverse chain rule tells me that because these are all 1s inside, multiplying or dividing by 1 is like, okay, plus dot, 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 right? And we're going to evaluate this t to 1. Now, when I plug in t, it becomes t minus 1 squared over 2, and then t minus 1 third over 6, plus t minus 1 fourth over 12, minus t minus 1 fifth over, I missed my thing right there. It had a 4 on it, so I went fifth over 5. There we go, caught that, over 20. And remember how it's like top minus bottom? Well, when I plug 1 into each of these, what happens? 0, 0, 0, 0. So it's just like minus 0. Okay? And then that's what I get. And it didn't really ask me for a general term, but let's see if we can like figure one out here. So all the zeros go away. Okay. So I'm not going to write that minus 0. So here we go. So it's t minus 1. Well, actually, it alternates. Let me save room for the alternating part. Okay. Now notice, this is now n equals 1, n equals 2, n equals 3. So to get that power, it's got to be n plus 1. And also, you guys, I actually didn't even think about this. I could integrate this. Well, x minus 1 to the n is x minus 1 to the n plus 1 over n plus 1. Okay? And so this is t minus 1 to the n plus 1 over, now n comes from the original function, and then n plus 1 comes from the integral, and then I have to alternate it, and it starts positive with the first term, so again I'm going to have to go like n plus 1 or n minus 1, and it doesn't really matter on there. And then at the end, plus dot dot dot. Okay? So, I think we're good. So, these elementary series right now, it's just a matter of like memorizing them and then writing them and doing stuff. I can substitute something in, I can multiply by something, I can take the derivative, I can take the integral. Those are like all things that we can do once we're able to, just clean this up a little bit, memorize our alternating series, okay? Or our elementary series, I should say. Not alternating because one of them isn't alternating, but memorizing our elementary series, we can do a bunch of stuff like that. Alright? Okay, amazing. Okay, so now we have one more test about alternating series. Alright? So we're going to talk about alternating series, which again means we know this goes plus, minus, plus, minus, plus, minus. Alright? Now, here's how this works. The alternating series, so this one, and this one. Now, what's the only difference between that? 1 is to the n, 1 is to the n plus 1. So it basically, the only difference there is, does it start with a negative or does it start with a positive? Okay. 3 conditions have to be met. All right. Let's look at the 3. Does it alternate? You got to check that. Obviously, really easy to see if it alternates. It's going to have a negative 1 to the n or a negative 1 to the n plus 1. Does the terms never increase in absolute value? Now, the reason it says this is absolute value, because remember, you're going to have positive and negative terms, plus, minus, so ignore the signs, and basically what this says is every term has to get smaller. Let's make sure that they get smaller every time. And then the last one, the limit as n approaches infinity of a sub n equals 0. So the last term is limit to infinity does equal 0. Now we have a test, the nth term test. The nth term test says the limit as n approaches infinity of this term, if it is not 0, it diverges. So now we're seeing if it is 0, it converges, but only if it's alternating, okay? If you have another series that ends up going to 0, but it doesn't alternate, you're not allowed to say it converges. You're just like not allowed to. All right, those are the 3 conditions that you have to meet every single time. Now, a lot of times, guys, I like to kind of just write out and like see what I'm looking at here. So when n is 1, this is negative 1 to the 2, which is positive 1 over 1. Okay? When n is 2, this is negative 1 over 2. When n is 3, it goes back to positive, because 3 plus 1 is 4. 1 over 3, negative 1 over 4, dot, dot, dot. Okay? So, you like literally go like this. Is it alternating? Check. Or you can say like, yes. Okay? Do the terms decrease in absolute value? Yes. Meaning, without the negatives and the positives on there, does 1, 1/2, 1/3, 1/4 get smaller and smaller and smaller? Yes. And then the last thing you do is you check it. Okay? Taking out the alternating piece. You don't have to like check that because the alternating just means it alternates. Do that. Does that equal 0? Yes, 1 over infinity is 0. Check. So you write this converges by, and then our abbreviation is going to be the alternating series test. Okay, sweet. Let's take a look at this next one. All right. We have, okay, alternating and n plus 1 over n. So let's see here. I'm going to list out a few terms again so I can see it. If n is 1, the first term is positive 2 over 1. If n is 2, the next term is negative 1 to the third. So it's negative 3 over 2. Positive 4 over 3. Negative 5 over 4. Okay? So kind of take a look at it. All right. First, is it alternating? Yes, it is alternating. Now, sometimes I go to the next, like I jump down to the limit one before I actually do that middle one. Hold on, guys. I've had to pause this a lot. One sec. Okay, so first of all, the terms are getting bigger, which means we cannot use the alternating series test. And then last but not least, the limit as it goes to infinity of n plus 1 over n. You guys remember when the terms, the degrees are the same on the top and bottom, it equals 1 over 1, which is 1, which is not 0. So we cannot use alternating series test. But because the limit went to 1, which is not 0, we can actually say this diverges by the nth term test. So usually when the alternating series test fails, you can jump down to the nth term test. All right? And those are your tests. So here's just a summary of your tests real quick. Nth term, geometric series, alternating series. All right? So that's what we'll be working on the homework for 9.4.